Okay, so we're going to find t-values. This is a t-distribution with a degrees of freedom of n minus 1. We're going to say that n is 10 in this situation. N will not always be 10. That means the degrees of freedom is 10 minus 1, which is 9. Now, what does the degrees of freedom mean? It just, the reason why we're subtracting 1 is kind of thought of removing an outlier and just taking 1 less. It'll make our data a little bit stronger. That's one reason why we do it. And what we use the degrees of freedom for our t-distribution is how steep it is. T-distributions are typically shallower than a normal distribution, which would look something like this. And that was explained to you last class. The larger this becomes, the steeper our t would become, and the more normal it would become. But if we're using sample data, we want to kind of flatten things out so that we have more chances spread out along the entire normal curve, the t curve, okay? So we spread things out, we're using a t curve. Now, if I were to find a 95% confidence interval, it would just be like a normal curve in that there would be 95% of my data between, instead of z values, 2 t values. Right? That's important to know. Because what we're going to do is we're going to use our calculator to find the correct t-value. Now, if there's 95% in between these 2 t-values, what would be outside of the 2 t-values? 5% for both of them, 2.5 for each individual. How can you calculate that? Well, you could take 100% in your calculator, subtract 95%, to get the amount in both tails, divide that by 2, and you get the amount in each tail. And you can do this for any confidence interval. So there's 2.5% here, and there's 2.5% here. There's a function in our calculator, like inverse norm, where you would take a percentage, plug it into your function, and it would give you the t-value that would be at the top of that percentage. So everybody in your calculator, go to second dister and go to inverse t. If you have an older calculator, you might not have inverse t. There's one on my desk. Thank you, whoever you are in this class that stole my calculator, for ruining class for others. Now, what you plug in here is the area. It says area in your little table. The area is your percent below that you want to find. And then they have the degrees of freedom, or df. If you do not have inverse t in your calculator, you're going to have to borrow another person's calculator. Second dister, you will look like this in your calculator. Second dister, INVT. That's not going to work. Yep. Yep. Some calculators don't have it, so we'll have to figure out what to do. Okay? You go INVT. Now, my calculator just pulls up like that. We would put the area below. I'm going to just try to find this t-value here. I could plug in the area below for this positive t-value, but it's probably easier to just work on one tail. So I will plug in 0.025, comma, my degrees of freedom, since my sample size is 10, is 9. So I plug in 9. In everybody's calculator that I have, it has area and df. For area, you put 0.025. Mr. Englander, you are ruining your neurons and the whatever stuff, fatty tissue that is surrounding your neurons. Exactly. By continuously using your phone throughout the day. Before you know it, you will not be able to do anything. That's great. Great for you. 9 for the degrees of freedom and 0.025 for your area. Press enter and you get your t-value. Now notice this is a negative value. That's okay. It's the negative t-value that we would have. It'd be between there and there. So that's how you find your t-value, negative 2.2621. That is the degrees of freedom. It's 10 minus 1. The degrees of freedom is always your, no, it will be your sample size that is given to you minus 1. It determines how steep your t-distribution is. Always minus 1.
Were you doing 10B or were you just doing an example?
I'm just doing an example. Let's do another example. Find the t-value that you would use for a sample size of 15 and an 85% confidence interval.
If we were asked to find the t-value, do we have to find like the lowest part and the highest part? Or
it's the same. It'll be the same. If I typed into my calculator inverse t of 97.25, 0.975 with a degrees of freedom of 9, I get the positive value, 2.2621. Okay? So that's why we just go with the bottom and we say we have both. If 85% is in the middle, what is in one of the tails? That's what you're trying to find. Is that far enough? Does that help? I could have just picked it up.
Oh, this is divided by 2. We do 0.075.
0.075. Check your answers with a neighbor.
We divided by 2, is that what it was?
No.
We get our negative 2.26, and then what do we do with that? Go to...
That's it. That's your t-value.
Okay.
Okay? Now I want you to find a new t-value.
New t-value?
A new t-value. I want you to find the t-value when your n is 15 that you would use for an 85% confidence interval.
So then you can just...
Nope, that's the exact same.
Oh, really? Okay, so
You just have to put in the area below for your area, the percent below.
what is it, 0.015? For my area?
Well, if it's 85% on the inside, it's 15% on the outside, divided by 2, 7.5% would be in each tail. Okay, since we're struggling, let's do 2 more. What I would do to find this t-value is I would say, okay, no. 85% on the inside. That means 15% is on the outside. If you need to use a calculator, do so. Divide by 2, and you get 7.5% in each tail. In my area, when I plug in inverse t, I would type in 0.075. My degrees of freedom is no longer 9, it would be 14. It would just have my curve kind of go higher than the last curve where the n was 10. Second distor, inverse t, 0.075. $14. Negative 1.523. Okay? So you would use a t-value of positive 1.523. Let's do one more since I showed you that. Find the t-value for a sample size of 30 for a 90% confidence interval. Check your answer with a neighbor. Awesome.
No.
It's the area below in your tail. If 90% is on the inside, how much are in each tail? Use Miss Mann's calculator so you know how to do it, Miss Martinez. No. What is the area that you'd put in? It is the area below. We would put in, for a 85% confidence interval, I'd put in 7.5%. For a 95% confidence interval, I'd plug in 2.5%.
For 90, would it be 0.05?
0.05 or 5%.
Oh, oh, yeah.
We should be typing in inverse T of 0.0529, getting us 1.699. This is not your lesson today, but this is something you need to know for the review and for the test. It was supposed to be part of your lesson yesterday, but we didn't have time. So now, we have plenty of time before our test. For now, let's go into our homework, and let's do 9, A, B, and C, which you couldn't have done for homework. And let's do 10B, which you couldn't have done for homework. Ready, set, go.
Is it asking us to, like, do what you just did with this?
Yes, says find the t-value used at a confidence interval for each of the following situations.
Are we using the 10 where it says 20 as the end?
20 is the n, 12 is the n, 15 is the n.
Oh, I was talking about 10B.
10b, you would use the 20 people that were sampled, yes.
We always put down the positive version of the number, right?
Yes, you put the positive version of the number. If you do not have a calculator, at least write down what you would plug into your calculator. And then borrow somebody else's calculator to plug it in. Not today. Yes. Sure. We're until 12:23. Got plenty of time. Yes, put the positive t-value down.
1.761. 3.12.
Yep, that's same.
Yeah.
Oh, okay.
And then 2.
I just rounded it. Yeah.
Check your answers with a neighbor. You just use the positive. And it's good. 14 and 5. Good. The degrees of freedom, which is one less than your sample size.
I'm getting you, Mr.
Okay. Here are our t-values. questions about these? Now, let's get ready for our quiz. We'll do 2.
Yes.
What?
I don't really like remember all of that well.
Can we do another practice?
I'm just saying, let's get ready for our quiz. We're going to do 2 practice problems. And we now have the capabilities of doing these problems 2 different ways, okay? You can just use your calculator, but I'll show you the other way to do it. Sure, 3 and 6. You just need to get the answers right, okay? On some questions on the quiz, they might say, what is the t-value that you would use? And you can't just use your calculator and plug in your sample standard deviation and stuff. 3, for the sampling distribution of x bar, the mean and the standard deviation. The mean is x bar, which is equal to u. And the standard deviation is equal to our standard deviation divided by the square root of n. We divide by the square root of n to kind of understand the situation of we have sample data and we're talking about the central limit theorem and we're shrinking what our sample standard deviation is. Okay? It's just something that conceptually is difficult to understand. You just need to understand how to do the calculations. Okay? What was the other one you need to do, Ms. Adams? 6. When using the t-distribution for inference about the mean, the formula for degrees of freedom is n minus 1. Or n is the sample size. Okay? Right? Degrees of freedom is just 1 less than the sample size. All right. Here's like a question you'd see on your quiz. The average height of 10 fourth grader samples is 48 inches with a sample standard deviation of 4 inches. Calculate a 90% confidence interval and interpret it.
So there's not any groups.
We're going to assume that it's average heights of sample sizes of 10 samples. Yeah, 10 samples of size 10, just to not have to worry about it too much. You can just use stat test 8. Go. Stat test 8 is t interval. Check your answers with a neighbor. Now, reminder from last class, stats test 8. You have stats and data. Well, we don't really have data. We have just statistics given. We have a sample height of 48 inches. We have a sample standard deviation of 4. We have a sample size of 10. 10 fourth graders in each group, 10 groups. We're just going to go with that.
But 10 stands for which one of those? So in the future, if it's not 10 and 10.
It will be obvious. There's only going to be one number, and you're going to use that number.
Okay.
Okay. I do know what you're saying. I don't want to confuse everybody else. You press calculate, and you get your interval, 45.681, 50.391. Did everybody else get that?
45.681?
Yes.
50.89?
Yes.
What's your ID on
Your confidence interval might have that 195.
Oh, that's right.
Make sure your confidence interval is a 90% confidence interval.
I just got -2.
Go back to stat test 8 if you did not get it right. 45.681, 50.319. Got it? Okay. Well,
Oh, they give us the X bar, we're not supposed to.
no, the X bar is 48 inches. That is the mean height. The average height was 48. We don't do proportions anymore. So this kind of unit is the same as last unit almost, except we're using what? Try it again.
Okay.
We are using average data instead of proportions. We're not using percentages, which is why kind of things are different. And we're using samples instead of proportions. Since it's samples, we have to divide by the square root of n. We could have found this same answer here using the formula x bar plus or minus t times the standard deviation, which is the sample standard deviation, divided by the square root of n. Let's see. Everybody find the t-value that you would use for this type of confidence interval. Go. What would be the 90% confidence interval t-value for a sample size of 10? What did you get, Mr. Holtz?
Negative 3.105.
3.105. Seems a little large.
I got negative 1.8.
Yeah, 1.8.
So I did intern it with the inverse T, and then intern it again.
Okay. In the inverse t, Mr. Holt, we should be typing in inverse t. The percent below would be 0.05, which is in one of my tails. The degrees of freedom is 9. What do we get? 1.8? 1.833. Great. Well, watch this. Everybody in your calculator, calculate the following. 48 plus or minus. This is the one thing that we didn't do last time, was find the 1.833 times 4 over root 10. We should get this and this. Go.
Got 50.21.
Good.
318, not 319.
That's because we rounded the t-value. We shouldn't have not have rounded the t-value. That was inverse t, 0.059, to find the correct t-value for a 90% confidence interval for a n of 9.
Okay, inverse T.
0.05 is your percent in your tail. 9 is your degrees of freedom. That's n minus 1.
Okay.
So then just go up and go up and then enter it and it'll come down and then you can go over and change the negative real quick.
Do we get it?
Yep.
Look at that. We don't have to use our calculator. This is going to be helpful because we might be asked for the margin of error of my confidence interval. If we have this, yes, you can subtract the 2 and divide by 2, right? Seems easy. Or we could do the 1.833 times 4 over root 10. That would be the margin of error. Now, the other type of problem you might see is something like this. I sampled 4th grader and found heights of these. Now, I don't want to get too into the sample sizes here. We're just going to say that it's the same as the amount of samples that I found. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll just say sample size is going to be 10. Keep it as 10. Don't worry. It'll work out. Now, in this, you can also do stat test 8. But you would use data. But you need to enter in this data into your list. Make sure you go stat edit. Okay. enter in your list of data, and then stat test 8. Make sure you have the data selected, and go from there. Frequency of 1 means each number you're using once, which is correct. Stat test 8, data, list L1, frequency is 1, it just means each number shows up once, confidence level is 90, calculate. And we get 39.029, 43.571. Now, we forgot to interpret these intervals, 43.571. What would the interpretation sound like? We are 90% confident that the average height of 4th graders will be between there and there. What would this look like? We are 90% confident that the average height of 4th graders is between this and this. Now, we could have also done this by hand just to show you. X bar plus or minus t times the sample standard deviation over the square root of n. Now, this case, n is also what? 10, right?
Or isn't it supposed to be 9?
We need to find.
Don't you go?
The degrees of freedom will be 9, but the n is 10. Okay.
Average.
We can find the t-value. 90% confidence interval, degrees of freedom of 9. We already did that. This is 1.833.
Is that a constant?
It changes depending on your confidence interval, and it changes depending on your n size. If I change this to a 95% confidence interval, it would not be 1.833, just like how we... If it was a 95% confidence interval, it would be inverse t of the percent in your tail with the degrees of freedom, which is n minus 1. If it's a 95% confidence interval, the percent in your tail is 2.5%. The degrees of freedom is n minus 1. In this case, the sample size is 10. Degrees of freedom is 9. Just learned it.
I think I just set up the problem. Can I tell you how to put the numbers in? See if I got it right.
Hold on. Now, if we want to do this by hand, we could go into stat, calculate one variable stats. Everybody go into stat, calculate one variable stats. Guess why we do that? Because it gives us our sample standard deviation, SX, 3.917. It gives us our mean, 41.3.
It gives you all that in the thing you had. It's just when we plugged into the calculator.
Right, but let's just say we didn't use stat test 8. We would do this by hand.
We can write that.
Now, calculate this using your calculator and confirm that it's equal to this. Go. You will need to do it because there will be questions on quizzes and on tests that is not just going to be, give me your confidence interval. It'll be, what is the sample standard deviation? What is the t-value? I agree, sure. I'm just saying we need to know how to find these values. We need to know how to find them.
If I can't use the inverse t, how am I going to find the like 1.83?
You'd have to use another person's calculator. That's how we're going to do it. You won't have it on this quiz today. Right. You can write out, Ms. Burke, what you would plug into your calculator. Okay? You'd write out what you would plug into your calculator. Are we confirmed that this is the same as this? Yes? Good. Okay, so now we have two ways to do things. That's your quiz. Your quiz are two problems pretty much just like that. There's two other types of problems. One is, what is larger? A 85% confidence interval or like a 90% confidence interval? A 90, right? If you have a 90% confidence interval, the t-value is going to be larger or smaller, I guess, than a 95. 95's t-value is larger. So that would be the value that you're multiplying by your standard deviation over square root n. Larger t-values, larger intervals, right? If n is larger, would your interval be smaller or larger? It would be smaller. The larger that this is in a denominator, the smaller this will be, the smaller your interval will be, okay? If this is bigger, this is bigger, this is bigger, this is smaller. Does that make sense? Larger confidence interval, larger confidence interval. Larger confidence level, larger confidence interval. Larger sample size, smaller confidence interval. You can even do tests using your calculator if you really wanted to. All right, pass up your homework.
I do not